3.2, solving systems of inequalities by graphing. Follow along in your notes packets on page 4. By the end of this, we will be able to solve systems of linear equations by graphing and determine the coordinates of the vertices of a region formed by the graph of a system of inequalities. Okay, so this concept, we will kind of lean on both graphing by hand and using Desmos or a TI-84 to graph these. Big picture, if you think about a regular linear inequality, we worked with this in the last chapter. You have to think about solid line, you have to think about dashed line, pretend like that line is straight, okay? And then you also have to deal with shading, okay? So if something is shaded above, it means that there are all of these ordered pairs that satisfy the inequality. If an inequality is shaded below, then that means all the ordered pairs below the line satisfy the inequality. So when we think about a system of linear inequalities, we're going to have two lines. So maybe a line like this. It's a really rough sketch, solid line, then maybe a dashed line like this. And then each of these lines would be separating the plane into a half plane. So this solid line would have above and below. This dashed line would have above and below. And they're each going to be shaded a certain way. And we're going to try to see where is the shading going to overlap. Where is the shading going to overlap? So that's the big picture. So instead of having the entire area above a line shaded, notice how this part of above the solid line is not shaded anymore because it doesn't satisfy the dashed inequality. So we have to keep both in mind. Okay. So when we have intersecting regions, it'll look something like this. So thankfully both of these are already in slope-intercept form for us. We can graph them. So I will put this one in green. We're going to have an open circle dashed line because of that greater than symbol. And so our y-intercept is down at 4 on the y-axis, 1, 2, 3, 4. And then our slope is 2, so we can move up to right 1, up to right 1, up to right 1, and we can keep moving. And then if we want to then draw a line, we can do that. Okay, and so let's see if this gives me what I want it to give. Okay, good. And then here's our dashed line connecting those points. And so what I'm going to do here, it's going to be a little bit different. I'm doing this because it's a system. Instead of shading the plane, I'm going to draw some baby arrows telling me which direction I would shade if I shaded the whole thing. Okay, so thinking about this top inequality, I'm going to test the origin because it's very clearly above the line. If I plug in 0 here and 0 here, is 0 greater than 2 times 0 minus 4? That's my question. So is 0 greater than negative 4? Yes. So we would shade this side. Okay, I'm not going to shade it because this is a system, and I'll show you why in a second. So let's graph the second inequality. That y-intercept is up at 3, and this is going to be a closed circle, solid line because of that less than or equal to symbol. And then using our slope, we can go up 1, left 2, up 1, left 2, down 1, right 2, down 1, right 2, and we can keep going. And then I'm going to create my line. So I want a solid line. I want it to have arrows on both ends, and I'm going to make it blue so that it matches. And so let's sketch that. Okay, so I have intersecting lines. And then if I were to shade for this blue line, if I were to shade above or below, I would want to shade below. Okay, you can test that by seeing the origin 0, 0. So is 0 less than or equal to negative 1/2 times 0 plus 3? Meaning is 0 less than or equal to 3? Yes. Meaning the origin is included, so we want to shade below. And so now what I'm going to do is look and see which quadrant, so there's this part, this part, this part, or this part, which of those 4 options would both graphs have shading? And so I see this part right here would only have the blue line solutions included. This part up here would only have the green lines solutions included. But if I look over here, I see, oh, this would be shaded below, this would be shaded above. So this is the part of my graph that has solutions to both inequalities. Okay, so you want to shade only that part. Pause the video, give this one a try. Focus on open, closed circles, dotted or dashed lines. Okay, hopefully you've given this one a shot. It should look something like this. Okay, I already graphed it before I started the video, so notice that this first one has a solid line, and then this bottom one has a dashed line, and then the area where they overlap is right here. Okay, I'm going to move on to the next example, separate regions. So going to be similar. We're going to follow the same process. So this top one is going to have a solid line. Y-intercept is at 5, down 1 over 1, oops, excuse me, up 1 over 1, up 1, right 1, and keep going, keep going, keep going. So then I can create my solid line with arrows on both ends, and I want it to be blue. And then it can go straight through here. Okay, and then if I were to shade, test the origin. So is 0 greater than or equal to 0 plus 5? Is 0 greater than or equal to 5? No. So we do not want the origin included here. We would shade above here. I'm just going to draw those little arrows. And then I'm going to graph my bottom inequality. Okay, open circle, dashed line because of this less than symbol. Y-intercept down at 4. Up 1, right 1, up 1, right 1, up 1, right 1, keep going, and you're going to see a pattern start to show up, and we can fill in this dashed line with arrows on both ends. I'm going to make the line green, and then let's get that in there. So if we were to shade for this part, what would we do? So let's test the origin again. The origin's right here. So is 0 less than 0 minus 4? Is 0 less than negative 4? No. Okay, think about your number line. 0 is here, negative 4 is here. 0 is greater than negative 4, so the origin's not included here either. So we actually are going to shade below. So there's not going to be an overlapping region. That's why this example is called separate regions. So all that means is that the solution, we're going to shade we would shade like this, okay, but because there's no overlapping, this is actually going to have no solution. Okay, so it's kind of a trick question. There are no ordered pairs that satisfy both, but this is what the graph would look like. Okay, so it kind of goes hand in hand. Pause the video, give this one a try. All right, it should look something like this. So again, we see there's no overlap in the solution set, which means that if we were looking at the system of equations, y equals negative 4x plus 8 and y equals negative 4x plus 4, this system of equations would have no solution. But the inequalities would just have separate regions. So it's the no solution idea with lines, with equations, is represented by this separate region concept. Okay. All right, I'm going to create a separate video for this problem so that I don't run too long. Take a look at practicing your systems of inequalities, and the next video is going to have using inequalities to find vertices.